Hi, everyone. This is Sridhar. Thank you so much for joining. This is a quick tutorial on what I saw last night, which is something called the Fireworks Galaxy, taken here in Livermore, California, using my EV scope telescope. That's a digital telescope, and this is over a 60-minute time period of exposure. So here it is, the Fireworks Galaxy. Now, what an interesting name, Fireworks Galaxy. The technical name is NGC 6946, NGC's new general catalog. This is a scientific catalog of all kinds of deep space objects. And the so-called number for this one is 6946. What is a few facts and figures about this Fireworks Galaxy? First off, it's 25.2 million light years from us. And that means it took 25 million years for light from this galaxy to get to our eyeball. To put that in perspective, remember the dinosaurs went extinct about 65 million years ago. That's when a big meteor hit Chicxulub, Mexico, the Gulf of Mexico, wiped out the dinosaurs, and that happened. So this galaxy's light left 25 million years ago, so not that far off from the dinosaur extinction. 10 supernovae are inside of this galaxy. The plural of supernova is supernovae, by the way. So 10. Now, 10 is a lot for one galaxy. And to put that in context, here in the Milky Way, this would be about 10 times the number of supernovae we have in our own galaxy. This galaxy is cranking out a lot of supernovae. So let's go to some basics. What is a supernova, or what are supernovae? These are exploding stars. Simply put, they're stars that blow up. And there are two ways that supernovae are formed. One is at the late stage of a very large dying star. This is after a star is burned bright for billions of years. The fuel that drives all stars is hydrogen. So at the core of all stars is hydrogen. And under high pressure, due to all the material there, the hydrogen is getting squeezed and converted into helium through a process called nucleosynthesis. And symbiosis, which is a compression of hydrogen, forcing the proton in the center and smashing them together to create helium, and thereby releasing huge amount of energy. E equals mc squared, by the way, is the formula. So one formula is that this dying star is running out of that hydrogen in the core, and because there's no more hydrogen, that means the outward pressure of the light and the gas is being overcome by gravity. The star is just so big, it no longer has an outward force, so the inward force pulling in all the material is now overwhelming the star, and it has this bounce back explosion. So that's one way that a supernova forms. The other way is you might have another late stage star. It's called a white dwarf. A white dwarf happens when a star is in its late cycle and it turns into a very small, highly dense core. It's not made of hydrogen anymore, but highly compressed material. And then this white dwarf might be attracting material from a sister star, and it's a binary system, and it's stealing material from that sister star, and it's acquiring more and more material. At some point, the same process happens with the white dwarf as happens over here with the dying star, which is gravity overwhelms the outward pressure of the force coming from the inner part of the dying binary system and the white dwarf. And this is a NASA image. Both of these are NASA images. This is an example of a white dwarf. You can see here, it's a tiny little image, but then when it's supernovaed over here, you can see that same image has brightened hugely. So supernova produces an enormous amount of light. So that little tiny dot is now this same part of the sky. You can see this image, very bright. So that's an example of a supernova. Now, what's cool about the supernova is we are made of stardust. We are here because of supernovae. Now, what I'm sharing with you comes straight from a fantastic article. I highly recommend this. This is called a Forbes article. What was it like when the universe made its heaviest elements? And this here is the periodic table. This image comes from that article. And a lot of the solar system elements, of course, come not just from exploding massive stars or from exploding white dwarfs, but also from the origin of the universe, the Big Bang. Now, let's talk about supernovae. There are these two sources, this color here, which is kind of a reddish, and the light blue, make up a lot of the human body. So let's take the 73%, mostly that's water. A lot of water makes up the human body. And guess what? Water is made of H2O, hydrogen, and two hydrogens and one oxygen. Oxygen comes from supernovae. That's how they're formed, oxygen, that element. So a lot of us come straight from the explosion of a star. There's a lot of other elements you can see here, like iron. Okay, of course, we have iron, we have nickel, cobalt, sodium, magnesium, potassium. You can see over here other elements, strontium. That makes up another percentage of the human body. So much of the human body comes straight from the supernova explosion. So there you have it. Hope you learned a lot today about supernovae, and keep looking up at the stars. They are amazing. Thanks for listening.